Hello, dear children. Chapter 2 Work and Energy. Let's continue with the word problems we were doing in our previous class. Let's revise the formula. Work is equal to force into displacement. Kinetic energy is equal to half mv square. Potential energy is equal to mgh. Power is equal to work upon time. Energy consumed is equal to power into time. Let's do the first sum. Swaralee takes 40 seconds to carry a bag weighing 20 kg to a height of 5 meters. How much power has she used? So 40 seconds means time is 40 seconds. 20 kg bag means mass is 20 kg. Height of 5 meters means height is 5 meters. So let's write the given. Mass m is 20 kg. Height h is equal to 5 meters. Time t is equal to 40 seconds. To find power. Now, let's write the solution. You know the formula of power. Power is equal to work upon time. Now, what is this work? Work is potential energy in this case because it is carried to a height of 5 meters means it's a potential energy. That means work is equal to mgh upon time. So mgh upon t. Now you know. Now in this particular sum, mass is 20 kg, height is 5 meters, time is 40 seconds. All the units are in the MK system. So there is absolutely no conversion. We can substitute the values. Now power, we do not know. We'll keep it as it is. Yes. Now M we know and H we know. Time we know. But what's the value of G? Yes, we know that G is equal to 9.8 meter per second square. So now let's substitute the values. Power is equal to 20 into 9.8 into 5 upon 40. Now you all know 21s are 20, 22s are 40. So now let's see 9.8 and 2. Both are divisible by 2. So 2 ones are 2 and 2 into 4.9. Now 4.9 into 5, when you multiply, you'll get it as 24.5. That means power Swaralee used is 24.5 watt. Let's go to the next sum. An electric pump has 2 kilowatt power. How much water will the pump lift every minute to a height of 10 meters? An electric pump has 2 kilowatt power. That means power is 2 kilowatt. Now 2 kilowatt is not the unit in the MK system. What is the unit in the MK system? That means a power has to be converted. 2 kilowatt has to be converted into watts. That is by multiplying it by 1000. How much water will the pump lift every minute? That means time is 1 minute, which has to be converted into seconds. 1 minute, minute is not the unit in the MK system. It has to be converted into seconds, which means that 1 minute is equal to 60 seconds. And height is 10 meters in the MK system, correct. So now let's write down, yes, power is 2 kilowatt and that is 2000 watts. Time is 1 minute and that's equal to 60 seconds. Height is 10 meters. It will remain as it is. To find how much water, that means mass of the water, mass M. So let's write down again the same formula. Power is equal to work upon time. And work is again now here, it is mgh because the water is pumped. So it means it's a potential energy, which is mgh upon t. So now power value, we will keep it as 2000. We have to write this 2000 value in place of power is equal to, yes, again the value of G is 9.8 meter per second square. So now power 2000 will be returned in place of power. Mass M you do not know. G value we will put it as 9.8 and H value is 10 upon T is 60. So let's substitute. Now try to understand this step correctly. The unknown mass M is here. 2000 is a power, so you put it here as it is. So please learn this. Now we have to cross multiply. 2000 multiplied by 60 is m into 9.8 into 10. So I'll write m into 9.8 into 10 is equal to 2000 into 60. Now m is the unknown. There's an equal to sign, right side here, left side here. So unknown m is equal to, the right hand side will be written on the numerator, and whatever is there along with the unknown will go to the denominator. Yes. Now, you can see there's a decimal point in the denominator. It's better we remove this decimal point, otherwise we'll have to divide by 9.8, which may be difficult. So how do we remove this decimal point of the denominator? That is multiplying the numerator by 10 and just remove it. Multiply the numerator, since the decimal point is in the denominator, multiply the numerator by 10 and the remaining things will remain as it is. So m is equal to 2000 into 60 into 10. And this 9.8 will be written as 98. That's what we are doing, removing the decimal point. Understand? Now this 10 and 10 will get cancelled. Yes. Now 98 and 2000 both are divisible by 2. So 2 into 1000 and 2 into 49. Now multiply the numerator to numerator. 1000 into 60 will be 60,000 divided by 49. Now, when you divide it, you will get it as 1224.48, which means you can round it off 0.48. This last digit 8 is more than 5, so we will add here, make it 5. So, m is equal to 1224.5 kg. Therefore, the mass of the water is equal to 1224.5 kg. Let's go to the third sum. A 25-watt electric bulb is used for 10 hours every day. How much electricity does it consume each day? So let's write down given. Power is equal to 25 watt. Time is 10 hours. So I kept it as it is. Yes. How much electricity does it consume each day? So the question asked is electricity consumed. Now, power is 25 watts, time is 10 hours. Let's write the solution. Now you should know the electricity consumed. The unit used to measure electricity is kilowatt hour, which means 25 watts should be converted into kilowatt, and the time will remain in hours. It is given in hours, it will continue to remain in hours, and the power 25 watts should be converted into kilowatt. So let's write down power is equal to 25 watts. How do we convert watts into kilowatt? Divided by 1000. Yes. Now how do we divide it? There are 3 zeros in the denominator. So shift 3 digits to the left in the numerator. Your answer will be 0.025 kilowatt. Time will remain as it is. Now you have to find electricity consumed. What is electricity consumed? Means energy. So you know the formula, power is equal to work upon time. So which means energy is the capacity to do work. So power is equal to energy upon time. So let's cross multiply. Energy is equal to power into time. So energy consumed is equal to power into time. That means electricity consumed is energy consumed. Now we will substitute the values. Power is 0.025 and time is 10 hours. So let's write the values. We'll multiply it. You know, we just have to shift to the right. When you're multiplying by 10, you will shift to the right. When you're dividing, you'll shift to the left. So the electricity consumed each day will be 0.25 kilowatt hour, and you have learned 1 kilowatt hour is equal to 1 unit. That means 0.25 kilowatt hour is equal to 0.25 unit. Let's do the fourth sum. If a 1200 watt electric iron is used daily for 30 minutes, how much total electricity is consumed in the month of April? So let's write down given power is 1200 watt is used daily for 30 minutes. That means time is 30 minutes. How much total electricity is consumed in the month of April? So time to find electricity consumed in April. So solution, yes. Now you know electricity consumed. Electricity is measured in units of kilowatt hour. Let's write down that. Yes, electricity is measured in units of kilowatt hour. That means a power 1200 watt should be converted into kilowatt, and the time 30 minutes should be converted into hour. So let's do that. Power is equal to 1200 watt. How do we convert it into kilowatt? Divided by 1000. Now you have to just shift the decimal point 3 digits to the left. So the decimal point is after the last digit, shift 3 digits, it will become 1.2 kilowatt. Now 30 minutes. Time is 30. How do we convert it into hour? Divided by 60. Now you know 31s are 30, 32s are 60. Now 1 upon 2, when you divide, you will get it as 0.5 hour. So we have got kilowatt and hour, power and time. Now what's the formula of electricity? Yes, electricity is nothing but energy. So you have learned the formula, power is equal to work upon time. Energy is the capacity to do work. So power is equal to energy upon time. Cross multiply, energy is equal to power into time. So now let's reuse these values of power and time. Yes, when you multiply it, you will get it as 0.6 kilowatt hour. Now, what's the question? Electricity consumed in the month of April. So, in the month of April means April has how many days? You know, 30 days. April has 30 days. So, that means this 0.6 kilowatt hour is the energy consumed in 1 day. So, 30 days means you have to multiply it by 30. So, let's do it. So, that means total electricity consumed in the month of April will be 0.6 into 30, and when you multiply it, you will get it as 18 units. That means the total electricity consumed in the month of April is 18 units. Let's go to sum number 5. Convert 25 meter per second into kilometer per hour. 25 meters should get converted into kilometer means divided by 1000. Seconds to be converted into hours means you will divide it by 60 into 60. So again division means it will be reciprocal of that. That means multiplied by 60 into 60. So now you can reduce. So the zeros get cancelled. The 0 also will get cancelled. Now 25 and 10, 5, 5s are, 5 2s are. Now 2 and 6 will get cancelled. Yes, 5 into 3, 15 into 6 will be 90 kilometer per hour. So our answer will be 25 meter per second is 90 kilometer per hour. Let's do the sixth sum. 18 meters per second into kilometer per hour. Again, 18 divided by 1000 multiplied by 60 into 60. So the zeros will get cancelled. Yes, the last zeros. Now 18 and 10. So 2 9s are, 2 5s are. Now 9 into 6 into 6. 6 into 6 is 36 and into 9. So 9 into 36 upon 5. This when you multiply, you will get it as 324 divided by 5. Divide it, you will get the answer as 64.8 kilometers per hour. That means 18 meter per second is 64.8 kilometer per hour. There's some assignment. Convert 36 kilometer per hour into meter per second and convert 60 meter per second into kilometer per hour. That's all for today. Thank you. With this, we have completed the word problems of the chapter Work and Energy. Now you can practice it. Thank you.